What are the forces acting on it when it is flying? What are
Gravitational force.
yes, go on. Here, when a aircraft is flying, we can find four types of forces are acting on it. One is the weight of the flight craft. When it is moving forward, certainly there is a push from the air. So there is a drag force. So thrust generated by the engine, and there is a lift because there is a high speed, and then the air also put the pressure from the down upward. So from the lower end, it will put the upward pressure. So there is a lift. So four forces will be there. You draw and just only draw. Do not need to draw the aircraft. You can make a simple box and write aircraft and mention these four forces are acting on it. Then you can remember, make a one box, or if you can draw this aircraft, very fine. Otherwise, you make a box, simple box. Sometimes we do it in this way: a box, a simple box, and then four forces, and name the four forces. And it will help you to remember what are the forces acting on a aircraft when it is flying. So simply, these are the way how to represent quickly. So aircraft having this type of forces, then you have to calculate. And then you have to calculate when it can fly. Not well as it can fly. We will come to the animation also, check the animation and understand. Two animations are going on. Try to understand and come out with your ideas. What are the things mentioned here in the two different animations? Think about it.
Minus 20.
In case of top animation, check the flight and the cloud are in two different direction. So if aircraft is moving against the cloud. In the lower one, the flight is moving along the movement of the air. So certainly it is carrying the speed of the air, and another top one is obstructed by the air friction more. So it requires more speed to fly quickly. So these are the things. So you have to overcome the frictional force of the air. Now, one important concept from the second law also you will find the impulsive forces. What is impulsive forces? A simple idea, I would start with that.
Force in time.
Okay. So forces which acting for a short time. So acting on bodies for short time, it is impulsive forces. We would also take first examples and also understand it. Is there any advantage or disadvantage of this? Hitting, jumping, diving, catching, kicking, many other things are good examples of impulsive forces. So these are the good examples of impulsive forces. Then what are the advantages or disadvantages? So some we may think about it. We would just go with some examples and questions to understand that. Impulsive forces, trying to thinking about that. Now question is this: why does a cricketer catches a ball dragging his hands backward? Understand this? Generally, cricketer, when catching a ball, he takes up the ball coming to him and he drags his hand backward. Why is it so? Is there any advantage or any disadvantage? What does it mean actually? We'll think about and we will try to understand the point. So the point is here. What is the point? The cricketer player lowers his hand while catching a cricket ball. The thing is this. This is the event we can see. then he allows what? Longer time for his hand to stop the ball. Ball is coming in a speed. So he allows a longer time to stop the ball. And it gives a benefit to him. What is the benefit? He doesn't get hurt quickly. Otherwise, there is every chance if he tries to stop immediately, his hand may get injury. But if he allows longer time to stop the ball, he remains unhurt. This is one point. Second question, I would also put another question. Also look at the question and the picture. Why does a person get hurt falling from a height, especially in a cement floor or a staircase? Why does it so? Why is it so? And we will also try to put this answer in this way. I would like to analyze the event. First, to analyze the event, to understand it. When a person falls from a certain height, and we are accepting that he is falling from that type of things in a cement floor or something like that, the floor doesn't yield, floor doesn't change itself. It remains as hard as it is. So if it is like so, then what will happen to the person? Then person, certainly the change in the linear momentum, total change in the linear momentum is produced in a smaller interval of time. So change, there is, as it is falling on the ground, so there is a little change in the momentum. And time is very short. If it is so, then floor certainly exert, so the floor will certainly exert a great force, a much larger force. And if there is a larger force, and due to that, person receives more injury. But if this is not this much hard enough, can we expect something different? Yes, we can expect something different. I would also go for that. So when a person falling on a hard rock, hard cement floor, persons gets more injury. But if it is not so, then what will happen? Another example we will take up. What is the necessity to use sand during long jump? We intentionally fall on a certain space on the floor, but we keep sand on that part. We know we will fall, and we keep sand on that place. What is the necessity to do that? Understand? So we intentionally do it, or sometimes we keep cushions. In case of high jump, if you have seen, a person will certainly fall from a great height, and cushions are kept. Then I will also explain this way. So this is when a person falls on a heap of sand, the sand yields, means it changes itself. And as it is changing its shape or position, rather actually not sand is changing its shape but positions, the linear momentum is produced in much longer time, not very quicker, and not if it is not quicker, it is not providing more force on the body of the person. Then average force exerted on the person by heap of sand is much smaller, and person remains unhurt. So how to overcome this type of injury? By this way we can do it. Suppose when I understand this one, I think, so simple ideas, and we will pass to the next one. Newton's third law of motion. Newton's third law of motion, check at the animation and to understand it. Right side animation, one ball is striking, the other is moving away. Then when it is coming back and striking, the other side ball is going outwardly. So it is going on. The bird is flying, pushing the air downward, and it can go upward. So these are the incidents we find every time. Newton says this, the basic principle behind it. The principles are actually developed from the nature or from the experiments. So to every action, there is an equal and opposite reaction. So Newton says the idea is simple but very profound. So every action, there will be a reaction. And when we are talking about force, we have to mention the direction. And if there is a possibility to say about the amount, so he mentioned both. He said amount will be same and direction will be opposite. This means, so here, in another term, we can say simply the force of the action and reactions are always equal and opposite. The idea is same, only in the language is little different, that much. So these are the ideas behind Newton's third law of motion. We will take up some examples to understand it, how it works, or how is it working in different spheres of life. So Newton's third law of motion, initially Newton proposed 5 laws, then it was reduced to 3 laws. Now, when a person hanging from a tree, what are the forces working on him? One is the simple that weight, downward, so to say, but actually we should say it is towards the center of the earth. And another force is working just opposite of it. That is, the tree is pulling up. He is not falling. So both the forces are working in opposite direction. But mind it, both the forces are not working on the same body, but on 2 different bodies. One on this person, another on the tree. So the weight is working on the tree and the pulling is working on the person. A person is rowing, moving forward. Generally, what he or she does while rowing a boat, she can do what? She can move the paddle. And by that way, she can only drive the water backward. If she can do that, then the boat will move in the reverse direction of the water. And actually the boat starts moving, or it's going on, it goes on moving. So in case of a person coming from a boat to the land, he just jumps, and at that time if he jumps, then he lands into the platform and boat moves just differently, just oppositely. So these are the things what we find here in many occasions. A rocket is launched. Why it is going upward? Because fuel is coming downward very fast, violently, you can say also, and rocket is injected into the upward direction. So these are the motion, action, and the reaction is this. Now here, and also a bus is moving on the road and there is always a push on the tire or on the road. So the 2 are the things. Tire pushes on the road and similarly road pushing the tire. So there is a little jerk going on all the time. Now one question is here, why can't a jet plane go up to the place? We find, so here is rocket launching from the NASA space station. No, it is from the NASA's rocket launching stand. Try to see this one. So rocket is launched. Along with it, there is one aircraft-like things. In that place, our astronomers are there. So carrying the spaceship, so rocket is launched. So spaceship is out of Earth's atmosphere. So spaceship reached outside Earth's atmosphere. From the outer space, how we see our mother planet Earth. It is blue planet. So this is the way how rocket is injected outside the Earth's atmosphere.